For image compression, one more effective technique is run length coding or run length encoding. So here the idea is the repeated pixels should not be stored individually. Rather, we can just store the pixel value and how many times is it repeating. So this kind of compression techniques makes more sense for images where there is lot of uniform text. A run is nothing but considered as a consecutive identical values, and here we will store the value and how many times is it repeating. It is not considered appropriate for images with natural photograph where there is continuous pixel to pixel transformation, the values are changing. So here first of all we scan the image data in order, and after that once we hit a run of contiguous values we count the run length and then we output a pair for each run. So if the images are binary the value will always alternate, and so rather than storing the value and the number of times it is repeating, we can just store the sequence of run lengths also. So consider if these are my values 5555 88 5 times 2 and 9. So I can store 5 is appearing 4 times, 8 is appearing 2 times, 2 is appearing 5 times, and 9 is appearing 1 time. So now this will take 5 6 plus 6, this will take 12 uh, bytes, but this will take only 8 bytes. So earlier the size was 12 and this is 8, so a reduction of 4 bits, which is the compression ratio is coming to 12 by 8, and so 1.5 is to 1. So in the case of binary I can even store like what are the contiguous values. So like here 5 5 5 3 2. So initially it begins with 5, and then the next number is for 1, and the next number is for 0 1 0 and so on. So documents are white background with occasional runs of black text or lines, and so fax style documents makes more sense for RLE. In the case of RLE inside JPEG, after we perform the discrete cosine transform and quantization, we can read it in the scan order, and then after that we can group the many zero valued high frequency to long runs, and then after that we encode non-zero coefficients. Then we can perform Hoffman coding on these. So it is very simple and fast, it is fully lossless, helps to recover the image as it is, and it can be easily applied on flat or uniform based regions, on fax kinds of images also, but it is poor on images with little repetition, and it can sometimes increase the file size in case if there is too much of transition at every pixel level.